Okay, so hello everyone. This will be the first video on the Java and the Java, like recursion versus the stack. So this is a very long debate we can see on the common forums, even with the common developers. Like some developers prefer to use the stack, and many of the developers who in the same as in me and the beginning of the playing around with the algorithms and playing around with more learning path and making the efficient code. So they go with initially they will go with they will go with the recursion. Now, before deep diving into the code and before deep diving into the concept, like in which scenario we can use the stack and which scenario we can use the recursion, let's talk about why recursion and the why stack. So many a situation like whenever we need a deep deep searching, or you can say the deep finding for any object. In that case, other than the loop, we go with some little advanced recursion option, just like a recursion of a method. And many a time, it is good to use a recursion, but in the nature of a Java, if you see the nature of a JMM, whenever we create a new method, it will be stored in the stack, the memory stack. So the creator of a Java, and the more precisely the Java community developers, they handle it accordingly, like whatever the method we are going to be written, it will be on the memory stack. So here, just note down the one point, and I like to highlight a one point here. The stack coming since you are using the method. So as per the Java methodology and as per the Java language nature, if we go and if we directly use a recursion within the method, so sometime it will be a little expensive in the terms of repetition, in the terms of memory uses, and in the terms of performance. And automatically it will be affect the time complexity of your algorithm, or in the way it will be increase the time limit of your program and the logic whatever you are going to be done with that. So many a cases, I feel like instead of going with the recursion, we can use the stack. I know recursion is super easy. We can do many things with the recursion we can't do with the stack uh, initially. But once you get habitual about it, then you can be do with the stack. So now, further without wasting the further time, let's open to the real life example. And in this example, I will going to be treat all the files which is in the specific drive, basically C drive for obvious, and we will going to be treat all the files which we have stored in the C. So first, I will going to be use the recursion, and then I will going to use the stack. So let's get it started. Okay, so as we see, this example actually demonstrate the file finding logic, and we were using the recursion at the line number 21. Thanks to the IED, it's been denoting the recursion impossibilities. If I can forward it here, so you can see it is showing the recursion. Now, this logic is super cool, but what point here is like uh, why I am having the issue with this logic? Because this particular statement and this particular logic will going to be execute each and every time whenever we are going using the recursion. So now think about the resources and think about the system where we have the limited storage, or we have a limited you can say the resources at the moment for the computing. So this logic is so cool for the beginning purpose, and until we have the trade-off in the case of this, the very popular case which I've been so far been seeing in the terms of the reflection API, or if you are dealing with the object mapper, or any sort of the mostly the runtime error throwing functionalities. So in that case, sometime you have to go with the recursion, because the things which you're handling with the recursion, you for a case you will not so precisely can handle with the stack. So there is a little trade-off, but yeah, all the time going with the recursion will be the not suitable. So this is little birdie. Now let's see the one example. Why so? So to demonstrate that one, let's go in the, where we go? Yeah, let's go in the terminal. Not the terminal, I guess CMD could be fine if I had set it my Java path. And here we should have to type, okay, Java C should be there. Okay, JVisual VM, if I tried it correctly. JVisual. I think that's the reason CMD is not always supported. Personally. Let's go and go ahead in the terminal. Okay, here I'm expecting it should be. Yep. JVisual. Visual VM. Man. Okay, so let me take you guys to the where. Yep. My C drive. Okay, here my C drive, E drive is totally empty. I don't know why I did that. Let's go here in the Java. I believe it's okay. This is the one which I'm using. Go on the bean. So this is a very popular tool which comes with the JDK, and one of my personal favorite whenever I go with some kind of research with the back and forth, just like back and forth with any certain things. So I go with the G Visual VM. But what I'm seeing, it is nowhere here. Why? J Visual. Let's see. J Visual. Where it is here? Should be here. Hmm, okay. Like I was not confident so with my spelling, so I just gotta check it here. Yeah, sometime. That's sometime. What is sometime? Hey man, where is J Visual VM? Okay, no worries. I think in that case, I think we have to go with I think the task manager, and in the task manager we have to go with where is the processor? This is the one. This is the one. Take down. No, 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 certainly no. Okay, this is the one which I'm looking for. Okay, so let it be like this, and let's be awaken the beast again. I know this is not so good for my PC, but let's see. Okay, here the party begins. Here too. So it's just eating the storage. It is just eating the process. So it's basically if I tell about my configuration, so it's AMD Ryzen 5 with the ribbon graphics, not of use for now. But the thing to be get noted, the CPU uses 49%, it's been increasing and decreasing at a certain time. But the memory constantly is being so high, meaning it's so high, which is not a sign of a good algo utilization and the host. All things has been going into the very drastic way. So think about the scenario when the job is really long running. This is a job which is not so long, which is a little about just for the file searching, though there is a tons of files to be get searched on, but yeah, it's still the same thing. Okay, again the same, just waiting to be get calm. Okay, okay, so now we can see the users, the memory. Memory is just like because of I'm just using the IntelliJ, which is comparatively little hard. But yeah, we can see the CPU has been decreasing, the disk usage, this GPU, everything has been now normalized since the our algorithm has been hit down. Now let's test it one more time. Okay, go ahead and run the beast. Okay, it's been started. Go ahead here. Again, CPU is on 65. It should count down. 71, 54. I really hate, but what to do? 71, 51. These should be silent now. Nothing on the peak. 54, 47, 54 again. I don't know what it's searching till now. It's just eating the CPU, as we can see. Oh boy. Okay, now I think it's completed. Okay, very happy. So as we see, like that particular thing was actually eating the processor like anything. So now go ahead and let's improvise our algorithm. Okay. So now we will going to be use the stack. I'm going to mute myself and then see what we can make a change here. Okay, so I was just initially writing my algorithm. So here you can see, like, if I explain you guys, so just bear with my code is starting. It's a old school. Just for the sake of this example, I'm just using it so far. So what we are doing here is, like, initially on the gateway of a method, I'm just pushing simply the path which I'm just calling from the main method, and then I was just checking it through, like, it should not be empty. So as we know, in the initial state it should not be, it will be not gonna empty anytime. And then just very immediately after it, we are just popping the value. So for a very quick, if people are not aware with the how stack works, so stack basically support a two operation, push and pop. uh, Push is for adding the element in your stack, and pop is basically to deleting, or you can say taking out the element which you just pushed on. So now it will be the very quick and very easy to get implemented, and the main objective for using this over the recursion, it's the resources and the performance. So now how we calculate the performance. So I think just for a sec, I'm just pulling you guys back to the recursion point. When we doing the recursion, that time we had been seeing a very heavy load which is on our CPU. But since we will going to be stack, so I think RAM could be a little high, not high due to the stack, but it's in general due to the ID. So sometimes it's also act like a beast. So it was eating the what can I say, the RAM of my system. But overall, the performance wise, the CPU load will be really very low as compared to the recursion. So we had the enough word. Now let's again rerun the beast. So now this time this process is not a beast. It's like a very sweet baby now. So let's go ahead and run it. Mhm. I had to open up the peeps. Okay, this is the part which I love so far. 74, 64, come down, bro. So won't gonna much. I think really it will go to 90 and the 60, which was so drastically using the time when we were using the recursion. Come down, bro. Okay, it's been a trading and a trading again. Just ignore this thing. Mhm. I think GPU has been relaxing for now, but I think it was way beyond when we were using the recursion. I think it's been ended now so far. Okay, so it's been ended. So I think just to let quickly kind of remind, so we had compared the two different strategies to have the stack, to have the recursion, and comparatively we had been seeing it in the performance part, why to go with the stack and why when to go with this recursion. So if you have the trade-off, I would suggest just to revisit your algorithm. Possible, just do it with the stack instead of recursion. But if you're in case if you're using a reflection API, if you're using the mappers or back-to-back, if you're using the parallel calling of a web APIs, then I guess there we have to be a little bit have the trade-off, because I know in the real time the resources here in the my system, actually we are recording in parallel. We are browser is also been open, and the main base is this, which is kind of my boy too, my loving boy, the IntelliJ. This is on my system, so that's also impacting the GPU and the CPU parallelly, also the RAM. So in the real-time environment, take an example for the EC2. If you are using the EC2 system, or if you're using any JVM-based hosting, so there your application will be run on the backend mode or either the service. So there will be no IntelliJ, no tool. So that time recursion will perform as well, you can say a little expensive only. So just, but comparatively, going with the stack will always be suggested. So if we can try to with the stack, it will be good option. But recursion in the hand is also a good option. It's easily readable, but you have to compromise with the performance. So that's all in today's video. Please do let me your thoughts and any suggestions about the coding style. I know coding style is really bad in this video because we can have the lambda, but to be very precise, I'm not a big fan of a lambda. So we can do the certain things, many things here. So just let me know if I missed any point, or if anybody like to correct me, and give a shout out if you find it helpful and cleared some ground. See you all guys next time. Thank you so much, and thank you so much for joining in. Cheers guys. Signing off now.